We're working on section 11.2, rewriting expressions involving radicals and rational exponents using the properties of exponents. So in the previous courses, we've used properties of integer exponents to simplify and evaluate expressions as shown. So we're going to work through a couple of examples here. So they're telling us a couple things. They're saying A is 64, B is 4, M is 1/3, and N is 3/2. So if we've got A times B to the N, A times B is 6 times 4, 6 times 4, then to the N power is to the 3/2. And you can plug that into your calculator, ends up being 4096. If we take A to the M to the N, so that's 64 to the 1/3 to the 3/2. 64 to the 1/3 is 4, so now you have 4 to the 3/2, which ends up being 8. Here we've got 64 to the 3/2 over 64 to the 1/3, which ends up being 512 divided by 4, which simplifies to 128. And then here we have 64 over 4 to the 3/2, which is 16 to the 3/2, which is 64. Now we're going to apply some of the rules of exponents we could use for integer notation. So we'll still end up here with 2048. Here we can break apart the exponents. So I have 64 to the 3/2 times 4 to the 3/2, which ends up being 512 times 8, which gets us 4096, same as the previous problem. So here we've got 64 to the 1/3. When you raise a power to a power, you multiply those powers. So we'll have to the 1/3 times 3/2, which becomes 64 to the 1/2, which is 8. When you divide with the same base, you subtract the exponents. So this will become 64 to the 1/3, 3/2 minus 1/3, which is 64 to the 7/6, which ends up being 128. And here we can separate these. So we'll get 64 to the 3/2 over 4 to the 3/2, which is 512 divided by 8, or 64. So we can see that they come up with the same answers from parts A and part B. So we can use these different power rules in rational exponents. So the product of powers property says when you multiply with the same base, you add the exponents. Add the exponents. Quotient of powers property. When you divide with the same base, you subtract the exponents. Power of a power. If you raise something to a power to another power, you multiply the exponents. Power of a product property. If you raise a product to a power, you can separate it out. You can distribute the exponents. And then power of a quotient, you can break apart. You can distribute the exponents to that quotient as well. So here's a couple of expressions they've worked through. So in A, since they're multiplying with the same base, you add the exponents. B, if you're dividing with the same base, you subtract the exponents. So here we've got y to the 4/3 over 16, y to the 2/3, that whole thing to the 3/2. So using the quotient property, we've got those two y values. You can subtract their exponents. So 4/3 minus 2/3 ends up with y to the 2/3 when we simplify. So now we can break apart that division, separate the powers. So that's the power of a quotient rule. So the power of a power rule says we can take that numerator, since it's already y to a power to another power, we will multiply those powers. So we end up with 2/3 times 3/2, which ends up being 6/6, which reduces to 1. So our simplified answer would be just y to the 1 power over 16 to the 3/2. Here we've got the power of a product property, so we can separate these powers here, separate these pieces. So Now we can use the power of a power property. We'll multiply 3 over 4 times 2 over 3. That ends up being 6 over 12, which is 1/2. Here we can simplify a little bit. I'm going to take the cube root of 27, which is 3, and then square that to get 9. So this will simplify to 9 square root x. Depends on how you want to write it. So if we want to simplify these expressions, here inside of the product, we've got the same base, so we can add the exponents. So I have 12 to the 2/3 plus 4/3. 2/3 plus 4/3 is 6, so we have got 6/3. So this is the same thing as 12 squared. When we're raising something to a power to another power, we will multiply the exponents. So we'll have 12 to the 2 over 1 times 3 over 2, which ends up being 6 over 2, which is 12 cubed, which is 1728. Here we can break apart the powers. So we'll get 6 squared, and then x to the 1/3 raised to that power, we end up multiplying the powers. So we'll have x to the 1/3 times 2 over 1. We still in our denominator hasn't changed. So from here, 6 squared is 36. This ends up x to the 2/3 over x to the 5/3 y. From here, we can subtract those exponents. So I'll have 36 times x to the 2/3 minus 5/3. Still got that y in the denominator. So 2/3 minus 5/3 is negative 3 over 3, which is -1. So then since that's -1, it's going to go down to the denominator. We end up with 36 over x times y. So when you're working with radical expressions involving nth roots, you can rewrite the expressions using rational exponents and then simplify using the properties of exponents. So usually you end up taking a square root, rewriting it as the power, and then applying these power rules to what you end up with. So here, numerator, square root of 64y, denominator, cube root of 64y. So rewrite that square root to the 1/2 power, cube root to the 1/3 power. Now we can subtract those. So 1/2 minus 1/3, which ends up being the 1/6 power. So we can now use the power of a product. We can separate that. 64 to the 1/6 times y to the 1/6. 64 ends up being a perfect 6th root. So simplified, we get 2 times y to the 1/6, or if you prefer, 2 times the 6th root of y. So we want to rewrite these in the numerator. That'll change to x to the 3 over 2, denominator x to the 2 over 3. So then we can subtract of x to the 3 over 2 minus 2/3. So that ends up being, what is that, 9/6 minus 4/6? Yep, 9/6 minus 4/6, which ends up being x to the 5/6 power. So here we've got 16 to the 3 over 6 times 4 to the 6 over 4 times 8 to the 2 over 3. So that's really 16 to the 1/2 times 4 to the 3/2 times 8 to the 2/3. That's 4, that's 8 times 4, which ends up getting us to an answer of 128. So from working with square roots, we can know some things about products and about sum division. These properties will also apply to nth roots. So the product property of roots says we can break apart a square root in both a product and in a quotient. We can take a product or a division and break apart the roots there as well. So we'll work through some examples of that here in the next video.